In the Star Wars universe, the Death Star is the ultimate weapon of mass destruction, able to annihilate entire planets. In the actual universe, the sky is filled with real-life Death Stars.
It can be thought of as sort of a time bomb.
Some are dangerously close to our planet.
Earth's life might take a bad hit when that radiation reaches us.
And one has the Earth in its crosshairs.
It was almost a shock. I didn't believe it when I first saw it.
They are the Death Stars, and they make the universe a very dangerous place. Thousands of light years from the Earth, a supermassive star is preparing to hit the self-destruct button. Stars explode every day in the universe, but this one is different. It lurks in the constellation Sagittarius, the mythological archer of the celestial zodiac. The star is called WR-104, and its destructive force could be targeting us and taking aim at our fragile blue planet with enough deadly radiation to ignite our protective ozone layer. This would incite drastic climate change, cause the extinction of many plant and animal species, and potentially the demise of mankind. WR-104 is just one of millions of massive Death Stars in the universe. These savage celestial bodies are aging giants, preparing to blast themselves into a stellar afterlife.
At that point, the outer layers of the star have nothing left to support them against gravity, so they suddenly fall inwards.
Their last breath can ignite the biggest explosion in the known universe. A gamma ray burst. A blast far exceeding the energy output of our own sun over its entire 10 billion year life. If one were to target the Earth, life as we know it could cease to exist. This is what could happen with WR-104, making it a real-life Death Star. In the film Star Wars, the Death Star is the dark side's ultimate weapon. The predatory star is pure science fiction, but the reality is much scarier.
A Death Star in real life is a star that blows up and blasts any nearby planets with deadly radiation. You know, that's a real Death Star.
WR-104 is what's known as a Wolf-Rayet star. They are the largest stars in the universe, hulking beasts 30 times bigger than our own sun, each of them counting down to Armageddon. Discovered by French astronomers Charles Wolf and Georges Rayet in 1867, Wolf-Rayet stars are the outlaws of the universe.
Stars live by the credo, live fast, die young, leave a good-looking corpse. And the bigger they are, the faster they live, and the faster they live, the more violent their end.
They burn through their nuclear fuel extremely quickly and exhaust everything that they have. And so consequently, they don't live very long, maybe a few tens of millions of years at most.
And they're easy to find because they're the real T-Rexes of the stellar kingdom. They're immensely powerful.
In the year 2000, Australian astronomer Peter Tuthill began studying Wolf-Rayet 104. Some 8,000 light years from Earth, this giant was ominously different from the others. Tuthill's team immediately noticed an immense dust cloud around it, 20 times larger than our entire solar system.
We knew there was dust around Wolf-Rayet 104, and that was a puzzle because it's a bit like finding a snowflake in hell. There was a mystery there, and we wanted to try and solve that mystery.
Over the course of 6 years, Tuthill used an infrared camera at the Keck Observatory in Hawaii to create a composited image from multiple exposures. It yielded an amazing time-lapse sequence. 104 was producing an exotic spiraling plume of dust.
It was almost a shock. I didn't believe it when I first saw it. I thought, stars don't look like spirals. There's no spiral I've ever seen in a book. We then had a mad scramble. We had to try and understand how a star can produce this elegant tail.
Tuthill discovered that the key to this strange dust spiral was the fact that WR104 wasn't alone. It's locked in orbit with a smaller star in what's known as a binary system. Both stars eject masses of charged particles called stellar winds. These winds aren't uncommon in the universe. Our own sun creates a solar wind that extends beyond the outer planets. The difference is that in a binary system, when winds from the two stars collide, gases are compressed and dust and soot are created. But what causes this dust to form into such an exotic spiral?
So it turns out that a lawn sprinkler makes a great analogy to illustrate the physics that's occurring in these colliding wind binary systems. We've modified this sprinkler so that it only shoots one jet out of the spigot.
The single water jet represents the constant flow of dust particles being created by the colliding stellar winds. But because the two stars in WR104's system are in constant orbit around each other, it adds a circular motion to the stream of dust.
Your first intuition is that the water is moving in a circular motion, but in actual fact, the lawn sprinkler is really shooting a jet in a straight line. The water droplets, even though they're moving in a straight line away from the spigot, they create an arc, and that arc wraps into a spiral with the rotation.
The spiral spawned even more questions. The most troubling, exactly what kind of Death Star could WR104 become?
Wolf-Rayet stars can be thought of as sort of a time bomb because they're so massive that they can't live for very long. And once they've burned up all of their nuclear fuel, there's nothing left to support the star against the relentless pull of gravity. And at that point, the core of the star collapses and the outer layers fall in on top of it and bounce outward in a tremendous explosion.
The explosion is a supernova, an immense burst of radiation that briefly outshines an entire galaxy. Wolf-Rayet 104 will definitely go supernova sometime in the next few 100,000 years. At 8,000 light years away, the explosion itself poses no threat to the Earth. But there's a chance the supernova will trigger the most violent event in the universe, a gamma-ray burst. In a small percentage of these massive Death Stars, a gamma-ray burst is triggered by the crushing transformation of a dying star into a black hole.
As a star collapses, it produces a massive electric field. And in an instant, the energy from this electric field is turned into matter and antimatter particles, which then collide with each other and produce a huge pulse of energy.
They are the most powerful energy beams in the electromagnetic spectrum, more lethal than microwaves, infrared energy, and even X-rays. Humans have learned to harness deadly gamma rays for useful purposes, such as food irradiation. By using gamma rays, food processors can eliminate microorganisms, bacteria, viruses, and insects. But the amount of gamma radiation applied is an extremely tiny fraction of the energy released in a stellar gamma ray burst.
Gamma ray bursts produce so much radiation that if we were to create a gamma ray burst on Earth, it would be like a huge number of nuclear bombs going off. It would be devastating for life on Earth.
For the human race, the most critical piece of information about gamma ray bursts is the direction of fire. At the moment of collapse, the star becomes a dense, flattened disk, and the rotational axis poles are its only openings free of dense star matter.
You get two relatively evacuated regions along the poles, and it's along those directions that material can be ejected because it encounters relatively little resistance. So this container of yogurt provides a nice analogy for what happens in a gamma ray burst. I'm going to drop the container of yogurt, and because of the sides of the container, yogurt is not going to be able to go out along those directions. But the top of the container is open, so yogurt is going to squirt out along the top. Watch what happens. So the yogurt went squirting basically straight up. It couldn't go out the sides because it was blocked by the sides of the yogurt container. And that's a nice analogy for what happens in a gamma ray burst.
The greatest concern for humans is the direction that the gamma ray burst is firing. If the axis of the collapsing star is pointing in our direction, we could be in serious trouble. When Peter Tuthill's team studied the plane of orbit of WR-104's dust plume, they came to a shocking realization.
This spiral was the key that unlocked a lot of these secrets. And where things start to get a little scary is that this system, at first blush, appears to be almost face-on. We're looking right down the axis at the heart. It's like looking at a plate, a dinner plate. If you take that plane and you tilt it to the line of sight, it looks inclined. You're no longer looking at a circular dinner plate.
Further examination suggests the rotational axis of the dust plume appears to match the rotational axis of the Wolf-Rayet star itself, meaning the Earth is staring directly down the barrel of a gun.
That means that if this star becomes a gamma ray burst when it blows up, one of the two jets will be pointing toward us.
The beautiful spiral of Wolf-Rayet 104 is suddenly a messenger of doom. Some 8,000 light years from Earth, two stars are locked in a gravitational dance. Their stellar winds ejecting a vast cloud of dust in a graceful spiral. But there's more to this star couple than just a beautiful tail. The larger of the two, Wolf-Rayet 104, is a massive Death Star on the verge of exploding as a supernova. That much is certain. The real mystery is, will it also unleash a gamma ray burst, or GRB, the most powerful burst of energy in the universe? The question is an important one for all on Earth, especially considering the star's axis may be pointing directly at us.
That means that when it blows up, if it becomes a gamma ray burst, the jet could be pointing straight at us.
WR-104 is counting down to destruction in the constellation Sagittarius. Named by Roman astrologers over 2,000 years ago, Sagittarius is Latin for the archer.
And you have to ask, maybe were the ancients onto something? Is there something to do with the archer aiming at us?
WR-104 can be thought of as an arrow pointing our way, if indeed it blows up as a gamma ray burst.
There is little dispute among today's astronomers that a tightly focused beam from a gamma-ray burst will travel vast distances in space. In fact, on April 23, 2009, the Swift Multi-Wavelength Observatory, orbiting the Earth, recorded a GRB that occurred 13 billion light-years away from Earth, near the very edge of the visible universe. The blast occurred only about 630 million years after the Big Bang. This means that gamma rays from the exploding star traveled at the speed of light for 13 billion years before they were visible to us, making this gamma ray burst the oldest stellar object in the known universe.
We know of no star or galaxy that's farther away than this gamma ray burst. It's the single most distant discrete object ever seen.
At only 8,000 light years, a GRB blast from Wolf-Rayet 104 could be catastrophic.
The flash that we would see if Wolf-Rayet 104 went off would be much brighter than the sun, especially at gamma ray energies. A single gamma ray burst can easily exceed the total light output of millions of galaxies. And each of those galaxies contains 100 billion stars.
This Death Star is a ticking time bomb. Scientists know for sure it will go supernova. But questions remain about its potential to unleash a gamma-ray burst in the direction of Earth.
That's the first point we need to establish. If it does produce a gamma-ray burst, is that gamma-ray burst pointing towards us?
The spiraling axis of the star appears to be aimed in the direction of Earth. But with thousands of light years to travel, would the GRB beam actually hit the target? Would the Archer's aim be true?
We know it's pointing roughly toward us, but it could be pointing sufficiently away that the beam of radiation from the gamma ray burst, if it turns into a gamma ray burst, will actually miss us.
However, if the star is aligned, one powerful burst of energy could turn the Earth's ozone layer into a radioactive inferno.
Even a gamma ray burst that's thousands of light years away could deplete the ozone layer to roughly half of its current level. Now that won't kill all of the species, but it could lead to what we call a mass extinction, where a good fraction of all living species die rather suddenly.
So the burning question is, will the death of WR-104 really trigger a gamma-ray burst? Scientists just don't know. The mandatory requirement for a star to produce a lethal gamma-ray burst is high horsepower rotation. All stars rotate on their axes. Some massive stars can spin very fast.
So the rotating star, the rotational energy is part of what produces the gamma ray burst.
If you can put the brakes on, if you can take that rapidly spinning star and slow it down before it gets to that stage, you've defused that bomb.
Based on mounting scientific evidence, it appears the universe itself is applying another set of brakes to its stars. It's called metallicity. Stars are primarily made of hydrogen and helium. But heavier, more complex elements are created every time a star explodes. Elements like carbon, nitrogen, and oxygen that then become the raw materials for the next generation of stars. So a star born today has more heavy elements, also known as a higher metallicity, than a star born earlier in the history of the universe.
When a massive star has a lot of heavy elements in it, it tends to lose a lot of its mass through winds. And if it loses a lot of its mass, it also loses a lot of its rotation. And it ends up rotating too slowly to form a GRB.
So something is happening to the Wolf-Rayet stars today that's going up there and defusing all the bombs. So they're still blowing up as supernovae, but far, far fewer of them are taking that supernova to the next step as a gamma ray burst.
Could these breaks slow WR-104 enough to render it harmless to the Earth? Many astronomers believe so. But what if they're wrong? At 8,000 light years away, is Earth really in the danger zone? When the Death Star, called WR-104, finally explodes, it has the potential to unleash a deadly gamma ray burst directly at Earth. It's believed the star is roughly 8,000 light years away from us. Is this close enough for a gamma ray burst to do damage to our planet?
Being 5,000 to 8,000 light years away, it's in the danger zone. Earth's life might take a bad hit when that radiation reaches us.
If it was another 2 or 3 times further away, we'd probably be okay. And if it was 2 or 3 times closer, we'd really be shaking in our boots. But it's just at the edge of its range where one would expect, well, you know, it might do something, but it's probably not going to roast us all in our sleep.
So perhaps once every billion years or so, there's a gamma ray burst that's sufficiently close and sufficiently well pointing toward us that we need to worry.
Death stars of all sizes populate the universe. But stars are not the only entities capable of such violence. The universe is also home to death galaxies, like 3C321, also known as the Death Star Galaxy.
3C321 is a galaxy with a giant black hole in the middle, millions of times the mass of our sun.
Just outside the black hole's edge, the chaotic churning of magnetic fields and gravitational pull has ignited a high-energy particle jet. These jets are not uncommon, but this one is delivering a beating to its nearest neighbor.
The case of 3C321 is very interesting because there happens to be another galaxy 20,000 light years away. The stars in that galaxy are being blasted by the energetic particles and radiation from one of these jets.
X-ray astronomer Dan Evans has been tracking the Death Star Galaxy and its violent behavior from the Chandra X-ray Satellite Control Center outside Boston.
So we see black holes do kind of strange things, but only a very small fraction emit these powerful jets of particles. And a fraction even smaller, such as the 3C321 galaxy, the Death Star galaxy, smack into other companion galaxies. So that's incredibly rare.
The companion galaxy is across the galactic street, 20,000 light years distant. The massive energy beam, even larger than a gamma ray burst from a dying star, is firing non-stop with a seemingly limitless energy supply.
So what we're looking at here is the best terrestrial analogy for the Death Star galaxy, 3C321. A jet is racing out of the black hole, close to the speed of light, and it's actually normally would propagate up to about 1 million light years away. But in the special case of 3C321, that jet is slamming into the side of the companion galaxy. And in doing so, it's becoming disrupted and distorted and bent away. And that's wreaking all sorts of havoc for that companion galaxy.
Much like the building is deflecting the water jet, the planets and stars in the victimized galaxy are deflecting most of the attacking particles.
So this jet is actually a massive beam of energy and particles. And these particles have been superheated such that they form a plasma.
Plasma is a mix of super-hot, charged electrons and ions funneled into the jet by the black hole's immense magnetic field.
So jets that race out of black holes are actually incredibly energetic, and in fact they can accelerate particles such that they emit light, maybe even up to gamma rays. These rays are incredibly powerful.
And very long-lasting. Some estimates say the energy jet from the Death Star galaxy has been firing for nearly 2 million years. For its fuel, 3C321 simply devoured an entire galaxy.
It's got a lot of fuel. What we actually think is happening here is that there's been a previous merger, so another galaxy has fallen in to the main galaxy. We see this beautiful dust lane, which implies that the galaxy has been shredded already. And so that act of shredding drives mass down onto the black hole.
After consuming another galaxy's provision of plasma particles, the Death Star galaxy has to somehow energize the particles into a jet. Black holes have powerful magnetic fields and super fast spin rates, a combination that somehow ignites the particle jet. Scientists believe the reason the jets fire in one direction has to do with all the dust and gas circling the black hole.
In the case of an active galaxy like 3C321, which has a supermassive black hole in the center, you'll often have a donut or torus of material surrounding it. In that case, highly energetic particles near the black hole can't emerge from that region through the donut along the plane of the galaxy. They can only emerge along this axis where there's relatively little obstructing material.
Unfortunately for the companion galaxy, it's staring straight down the donut hole, and the jet's zone of impact is like the widely scattered blast of a cosmic shotgun.
The problem with this jet of high-speed particles and radiation hitting the little galaxy 20,000 light years away is that the jet is wide enough to encompass a large number of stars in this galaxy. So any creatures living on any planets, orbiting any stars in that galaxy, are in serious trouble right now.
What if it were our own Milky Way being blasted by the Death Star galaxy? Put Earth in the path of the jet, and the effect on the ozone layer would be enormous and deadly.
The gamma rays from the jet in 3C321 convert nitrogen gas into nitrous oxides, and it's those nitrous oxides that actually act as a catalyst in the destruction of ozone. So within a matter of weeks to months, maybe up to a year, the ozone layer will be completely obliterated. That's a nasty consequence.
But like many phenomena observed in the universe, there is a recurring paradox. From death comes life. 3C321 not only destroys, it also creates.
It's one of my favorite things about 3C321 is it demonstrates really clearly that black holes don't just gobble everything up in the universe. They're not all complete harbingers of destruction. The jet that is coming out of 3C321 is hammering into the side of the companion galaxy, and yes, of course, that's a destructive force. But the ultimate legacy, actually, is that the gas clouds that get compressed during this interaction can actually form stars, and the stars can form planets, and the planets may even form life. So this is beautiful cycle of birth and rebirth and destruction that's synonymous with the universe and black holes.
One day in the future, our own Milky Way could form its own merger with the nearby Andromeda galaxy and create a new Death Star galaxy, a violent act that would certainly spell doom for the Earth. Such an event would likely occur many billions of years in the future. But there are other stellar threats streaking through our galaxy at high speed. They are hypervelocity stars, and nothing can stop them. To the human eye, stars paint a tranquil picture in the heavens above. But take an up-close look. A select few are Death Stars on the verge of extinction, and these cosmic beasts are anything but peaceful.
Eventually, a star will burn through all the hydrogen in its core and convert it all to helium. Once it does that, it has to be massive enough to be able to ignite the helium and convert helium into heavier elements like carbon, oxygen, and nitrogen. And this releases an enormous amount of energy. This process is the same release of energy that goes on inside a hydrogen bomb.
Though they are incredibly violent, most of these stars will one day burn up and slip quietly into the afterlife as stellar corpses called white dwarf stars, smallish balls of electrons and nuclei destined to never again burn brightly. But some are supermassive stars, so energetic they end in a fantastic supernova explosion, and sometimes even produce the largest of all blasts, the gamma-ray burst. But for a few massive Death Stars, the end is a new beginning. Consider the second life of a neutron star. When a massive star explodes in a supernova, its core sometimes collapses to form a black hole. But much more frequently, if the core isn't massive enough to create the black hole, it forms something almost as weird, a neutron star, a small but incredibly dense body.
It actually has a huge amount of material compressed into a very small space. So you have, for example, the mass of our entire sun squeezed into a space maybe only a couple of tens of miles across.
The gravity is so strong that the protons and electrons inside the atoms of the star are actually pushed together to form neutrons. And a neutron star can remain stable for billions of years.
Neutron stars by themselves pose no danger to their celestial neighbors, unless they can find a partner.
You can also get another death scenario for stars where there's a sort of mutual suicide pact between two neutron stars.
These are called co-orbiting neutron stars, a phenomenon initiated when two neutron stars begin an intimate but doomed relationship. Their orbit narrows over millions of years until they finally meet in a flash of light.
And in so doing, they can generate a violent explosion, a second life in a sense.
So there's two different types of gamma ray bursts. There's short bursts, which have durations of less than 2 seconds, and we think that short bursts are produced by merging neutron stars.
The short bursts are different than the longer GRBs produced by collapsing massive stars. The gamma-ray burst emitted by two colliding neutron stars may be short, but it's powerful, equal to the energy released by the sun over its entire lifetime in less than 2 seconds. The worry for us? At least 24 pairs of orbiting neutron stars exist in the Milky Way.
A very nearby gamma-ray burst, first and foremost, would get rid of much of the ozone layer. That could have disastrous effects on Earth.
Some estimates hold that a violent neutron star merger occurs within about 3,000 light years of the sun every 100 million years. That's about the same interval as the mass extinction events recorded in the Earth's fossil record. Is it coincidence, or should we worry that the last tango of two dying stars might eventually blast the Earth's ozone layer with deadly gamma rays and alter the planet? Scientists don't know the answer. The chances are probably about the same as a runaway star plowing headlong into the Earth. It's a remote possibility, but fearsome to contemplate.
You could actually have the possibility that a collection of stars that perhaps were all together in the same neighborhood interacting with each other sometimes ejects a star just to wander off on its own. As far as we know, there are no wandering stars headed our way, But if that were to happen, it could be quite interesting.
One scenario could see the Earth's orbit around the Sun disrupted by the gravitational pull of the wandering star.
One dramatic possibility is that such a wandering star simply kicks the Earth entirely out of the solar system. And so we're now wandering around without a source of energy, the Sun. No one really knows what would happen. It really depends upon the angle of approach, the mass of the star, etc.
Wandering stars can travel up to 60 miles per second. Fast, but still not fast enough to escape the Milky Way's gravitational pull. But there are some supercharged turbo models that could actually break free and rocket out into the universe. These are called hypervelocity stars.
Hypervelocity stars are normal stars like the Sun, except that they're moving out of the galaxy at well over 1 million miles an hour. And that's beyond the escape velocity of the Milky Way.
The need for speed begins with a normal pair of co-orbiting stars that get too close to the edge of a black hole. Just as the disabled Apollo 13 command module got a boost of velocity by maneuvering close to the Moon's orbit, the hypervelocity star gets a huge gravitational kick from the black hole, severing the bond with its binary partner.
The star closest to the black hole is captured into a very tight orbit around the black hole, and so it loses this energy. The other star gains that energy and is ejected with this very large velocity as a result.
The ejection of a hypervelocity star is much like a slingshot effect. At the instant the binary star's orbit is broken, the hypervelocity star is launched with incredible force into the void of space.
They've been voted out of the Milky Way, and they're destined to drift into the infinite depths of intergalactic space. It's very unlikely that these stars will ever affect the Earth.
Fortunately, the eventual death of these speedy stars will occur far away from our solar system. It's the death stars on our own block we need to keep an eye on. In cosmic time, their fuses are lit, and we have a front row seat to their annihilation. In remote corners of the universe, countless stars are biding their time on death row, sentenced to spectacular, violent endings. Closer to home, there are a few dozen stars within 20 light years of the Earth, and a few of these are preparing for death.
I think we're safe from the dangers of a normal supernova. In the case of a gamma-ray burst, we're not so sure.
One is in the stellar system Eta Carina, a supermassive star about 100 times bigger and 1 million times more luminous than the Sun. In 1843, a buildup of pressure ignited a gigantic eruption of light seen from Earth. But the star survived and formed a dust cloud called a nebula. At a distance of just 8,000 light years, we'll have a front row seat to its annihilation.
We think it's going to turn into a black hole sometime between now and the next 1 million years. And as it collapses, it has enough matter that it can produce a powerful gamma-ray burst.
Unlike the star, Wolf-Rayet 104, Eta Carina doesn't have us in its crosshairs.
We know that the rotation of Eta Carina is not pointed towards Earth. So lucky for us, the pulse of the gamma ray is not going to be directly impacting Earth.
When it happens, the explosion will likely be the brightest supernova ever witnessed by mankind. Unless the title goes to another Death Star contender that's even closer to Earth, Betelgeuse. Located in the Orion constellation about 500 light years away, Betelgeuse is quickly burning through the last of its nuclear fuel.
Betelgeuse is a very massive star, about 20 times the mass of the Sun, and it's within 500,000 years of exploding.
People have been noticing that Betelgeuse has been changing a lot over the last decades. It's actually shrunk considerably, about 15%. What that means, no one is sure, but everyone's keeping an eye on it.
Some scientists believe Betelgeuse could unleash a gamma-ray burst. People on Earth have little to fear if it does. Like Eta Carina, the star's axis points safely away from Earth. Not only that, but Betelgeuse may also have a built-in blast shield.
Its explosion will be relatively normal. It won't be a gamma-ray burst because there's this thick hydrogen envelope in Betelgeuse, and that hydrogen envelope will probably prevent the jet of particles and radiation from emerging. There's too much material through which the jet of radiation would have to pass.
Betelgeuse will shine intensely for a brief moment, but it won't compare to the final moments of our nearest star, the Sun.
Average stars like our Sun have nice long lifespans, fortunately for us, and our Sun is about halfway through its 10 billion year lifetime, so it's about 4.5 billion years old. That makes it middle-aged.
Scientists estimate that the Sun will live another 5 billion years. But our problems could begin much sooner.
Our own Sun is very gradually getting brighter, getting more powerful. And within 500 million, certainly 1 billion years, the Earth will become so hot that the oceans will have evaporated away. So we don't quite have 4 or 5 billion years to worry about this problem. We have to worry about it on timescales of hundreds of millions of years.
Billions of years after the Sun renders the Earth devoid of life, it will enter a final phase known as a red giant. It can't explode and produce a supernova because it's not massive enough. But most scientists agree on the final chapter. As a red giant, its density will decrease, and the Sun will balloon outward, devouring its nearest neighbors.
At this stage, the red giant stage, the Sun will probably expand and engulf Mercury, Venus, and maybe even Earth itself. So that would pretty much be the end of Earth.
Of all the dangerous Death Stars in the universe, the one most likely to destroy the Earth is our own Sun. While it marks our planet's ultimate end, it's merely a part of the cycle of creation. Death Stars take life, but they are also the origin of life.
The heavy elements in our bodies, quite literally, were generated by previous generations of stars and ejected into the cosmos by stellar explosions. So we would not be here if it were not for the fact that some stars explode violently at the end of their lives. As Carl Sagan used to say, we are made of star stuff. We are made of star dust.
As the explosions continue, the resulting heavy elements may one day reseed the very foundations of life, far from the Milky Way, on a new blue planet, in a new corner of the universe.